Did anyone try this? Did anyone try to make this program? Okay, let us do this here. You remember that car parking area program, right? You remember car parking area program. You all have made that. But in that you have used which instruction? CTUD. Let us make this here. We shall replace that CTUD with arithmetic and compare instruction. So it was I0, just a minute. It was I0, latch with M0. From M0, we take gate 1, correct? From M0, we get first one on. That is Q0. This is the first gate, entry gate actually. Q0 on. Now when gate is opened, and I1 sensor gets high, and low. So negative pulse wheels on and off, I1 on and off. Then M1 comes and it breaks output, means gate is closed. Okay, gate is closed. The same thing we do for exit gate also. So we take here I2. I2, just a minute. So we take I2 and we latch it with M2, I2 latch with M2. Okay. As it is latched, we get exit gate open, right? So from M2, we get Q1 on. That is our exit gate. And when exit gate is open, means M2 is on. M2 on means gate is open, right? No, exit is opened. And I3 gets on and off. It means I3 on and off means negative pulse. And what we get? M3. What will happen now? From M3, switch off this exit gate. So M3 will switch off this exit gate. Fine. Now we have to display the number of cars, and we have to add one interlock that when parking is full, when 10 cars are inside, block entry. So for that, let us take increment decrement. You have made this using CTUD. Now the same we are making with increment decrement. So here we will have to take, this is entry M1. So M1 is already getting a pulse, you see. Negative pulse is here, no? So M1 is already getting a pulse. So no need to take pulse after this. So directly M1 is a pulse. Already M1 is a pulse here. So I'm not taking pulse here, or else I need to take pulse. So it is not required here. We take here increment, that is add, correct? We take here add block. Here we give percentage M W1, correct? This is the source one. Increment by 1, and this is the destination. You know, it should be the same percentage M W and 1. So now whenever M1 gets high, it will count once, 1, 2, 3, 4, it will show here. And decrement will start from M3, correct? When M3 gets high, means one car went in, outside. So for that, we take M3 and decrement block DC. Okay, decrement. So again, the same variable. Where you are getting increment, on the same location you need decrement also, no? So you have to keep it the same. Decrement by 1 and percentage M W1. Okay, so increment decrement we got here. After increment decrement, we have to get after increment decrement, let us take compare, means its value MW1 value here you see, here also MW1, here also MW1, because you want increment and decrement on the same location, that is MW1. So here in increment also I have taken MW1, and in decrement also MW1, because on the same display you want increment and decrement both. Now its value should not go above 10 and should not go below 0, right? So here we shall not put any condition. Here you see I'm not taking any NO here. So always it should be comparing. So I take here EQ or greater than equal to. Any we can take. We can take equal or we can take greater equal. So now it will compare MW1 with 10. So when MW1 value is equal to 10, let us generate one flag. That is M4. This will block entry. Okay. Okay, fine. And Let us compare with 0 also. So here I take less than or less than equal to. Here it will compare the same location MW1 with 0. So when MW1 value will decrease and will reach to 0, let us generate one more flag, that is M5, say M5. Now it will block decrement. So it will block exit. If we don't have any car, inside the parking area, then exit will not get open. So we put this compare here. That is it. So these have replaced CTUD. So same thing we made using arithmetic operation. Note this down, please, and ask question. If you have any doubt, we shall discuss. Let codices get open. It has been opened. 2 files got opened. Here. So let us take a new file. I hope you remember codices. We have to select LD here, make it okay. And here I take an O, latch it, break it, and one coil. Negative NC. Let me give the address percentage IX 0.0. Let me try this. It's coming. 0.0. Then here it is percentage MX 0. Sometimes it comes 0.1. And here it is percentage MX 0.4. Here it is percentage MX 0.0. Okay, 0.0. And here also percentage MX 0.0. Now let us copy paste Control CV. And here it is percentage QX 0.0. These two are not required. Even this is also not required. Now we need here copy paste. And here it is M1 Here it is M0 plus percentage IX 0.1. Correct? One negative pulse, go to function block. In function block, you have F trigger, F trigger. Here you can give any name. Fine. So this is for increment. We need to take decrement, control C, and here we can paste it, control V, and can change the things. Here it is I2 will be broken by M3, and it is 5. Here it is 2. Here also it is 2. Now again, we go to this ladder, copy and paste, control V. Here it is M2 and here it is Q1. Now again, we copy this flag, negative pulse ladder. Here it is M2, I3, 3 no, I2 we have taken, so I3, change the name, and here it is M3. Got it? Now we do compare. So this is the program. Now we do arithmetic increment decrement. So when have we to start increment? When we get percentage mx 0.1, right? This is for increment. For increment, you see how to take right click, box with enable. There you have to type add, click outside, give here percentage MW1, increment by 1, and here the same percentage MW1. Got it? So this is for increment. Now you want the same for decrement where you have the address M3. Here you have to make subtraction SUB, same thing, no changes, no other changes. Now we want compare. Again, in compare I told don't put any condition because compare should be continuously high. So continuous compare is required. So I have not given any condition. So direct supply will go there. So it is greater than equal to or EQ also you can put, there is no problem. Here it is percentage MW1 should be compared with 10. Okay, should be compared with 10 and again some flag will be generated, that is M4 we have already taken. Now we need to have copy, paste, or you can take new ladder also, no problem. Now this is less than equal to. Now it compares with 0 only, correct? It compares with 0 1. And the flag we generate is 5. Done. Let me save this. We shall save this on desktop. It is INCTC. Okay. Now let me show this in visualization. It would be more clear. We need to take here 4, 1, 2, 3, 4 push buttons, right? So we had this car parking area, no? And here we had taken one gate. We had 2 sensors here. Okay. So let me give the address, color. Okay. Then variable percentage IX 0.0, right? And here, either you take tab or toggle, no problem. ih 0.0. So this is your first input and this is the first output. Let us give some color and variable will be percentage qx 0.0. Now we copy this one, control CV, we take it here and we just change the address to 1 and here also 0.1. Okay. Now we copy all systems, control CV, and we take this here. Correct. Now we put one inside. So 0, 1, this is 2. So we make it 2, here also 2. And this is Q1. So we make it Q1. This is 3, 3. In input also it is 3. Now we need to display the value. What is the value? So value, we have increment, decrement, MW1, right? So I take here text percentage MW1 will increase the sorry, it is percentage smallest, right? Percentage smallest. And let us increase the font size. You can take separate new block also for displaying the things. And variable change color, no change color, display, text display percentage MW1. So here it will show you percentage MW1. And you know, you can display like parking is full or empty. Empty leave, parking full we will show. So when parking is full, we will make it red. And when parking is empty, it is green. When shall we change? When percentage mx 0.4 comes, parking full, right? No, you remember, no? When m4 comes, parking is full, we have broken the first latch. So here it will show either parking is full or not. Even you can give the text also. Like parking full. Parking full. See, initially, when I give it some, you see, I'll show you. See, it will show you parking full, but initially it should not show, no? So what shall I do? I shall change its color, text color. It is black, no? I shall make it green. This text color, I shall make lime green. So what will happen? You see, initially it is there, text is there, but font color and background color, both same. When it will become red, then that will be visible, green on red. Now let me show you. Login, run. So as you press it first time, gate is open, you press and leave. It is 1, right? 1, 2, correct? 3. Even it will go down also, see. Down, correct? Right, no? Let me make it count 5. Compare with 5. 10 means I will have to count more. Let me compare 5 only. Just to get the parking full, I have made that 5. Okay. Okay. 3, 4. Right now you see. Now you see it will come parking full. Has it come parking full? Because 5 counts over. And when MW1 value has become 5, it is compared with 5, right? MW1 is compared with 5 and M4 has been breaking first latch, correct? M4, you see first latch. M4 is white, NC is white means it is breaking. So M4 has come when you compare with 5, see, equal, right? 5 equal, so M4 is high, you see, blue color. That's why you get there parking full. And as any car will go outside, you see, parking is available, right? Available. And you know, when it would be 0, it won't go below 0 because you have compared there also, right? Now you see, now the gate is not open because it is 0, because it is 0. And here, when 5 cars will be inside, parking will be full, then gate will not be opened. You see, now you see, gate is not open. This is not open. This is not opened. Got it? So this program we have made using arithmetic operation and compare instruction. I shall share this program in group also. You go through this and try to make this yourself also in Codesys software if you have. Okay, fine. And one program I shall send you sometime for practice, arithmetic operation practice. Thank you. Good night. And many congratulations for Chandrayaan 3. Thank you. Good night.